Back. So we are doing oxidation numbers today. At this point, like I said, you guys should have your notes out, and you guys also should have your purple sheet with the oxidation numbers on it. It should look something similar like this, but actually it looks probably better than this. So let's talk about, before we talk about how to figure out oxidation numbers, we want to know why we worry about them in chemistry. Well, in the book, you're supposed to take notes about what oxidation numbers were. You guys are supposed to practice them. And in the book, oxidation numbers is defined as the number of electrons that must be added to or removed from an atom in a combined state to convert the atom into the elemental form. Whew. Okay, a little crazy, way too much for us. What we want to know is right here, the distribution of electrons. This is going to keep coming up over and over again. Electrons, electrons, electrons. So now today we're talking about specifically distribution of electrons. Where are electrons going? What element's giving them up? What element's taking them? And that's the whole goal. And we want to know this because if you're giving up electrons, if you're taking electrons, that's going to change your properties. That's going to change if you're going to give off heat, if you're going to take in heat, if you're going to change color, if you're going to react with vinegar, let's say, as in one of those white powders that bubbled up. Giving or taking electrons is going to tell us a lot about the electrons and a lot about the atoms without doing chemical experiments on them. So, there are 8 rules that you guys should already have down on that purple sheet. We're going to go over them, and we're going to figure out what they all mean. So, let's get those rules out. And by the way, oxidation numbers are also great for writing formulas, naming compounds, and balancing chemical formulas. But the 8 rules we want to talk about. 1. All pure elements have oxidation numbers of 0. So if you see any elements chilling by itself, as in Na, O2, P, zinc, whatever, if you just see an element, it has 0. Now, why does it have 0? I need you guys to stop this, pause it, and talk to your niche mates for 30 seconds of why a pure element would have an oxidation number of 0. I know it's Friday. Hopefully some of you guys tried. Hopefully some of you guys figured out that we just said that that oxidation numbers are the distribution of electrons. Well, if you have a pure element, if you have sodium just chilling by itself, it's not going to distribute. It's not going to give out electrons. It's not taking out electrons. It's chilling by itself. Hasn't done anything. Kind of if you guys were having money in your wallet. If you have $1 in your wallet and you walk down the street, how much money have you lost? Well, you haven't given any away, you haven't taken anything, you walk down the street. So you have 0 distribution of your money. Same thing with any pure element. If a pure element is just chilling by itself, there's no reason for it to give up electrons, so there is no distribution of electrons. So if you guys ever see an element chilling by itself, you would just write 0 above it. As in, if I have an example, example 1, let's say there's zinc. And it's just chilling there. And that's it. If you have it on your worksheet and it says zinc, there's nothing for it to do. It's just chilling there. So you would just put a 0 over top of it. And bada boom, bada bing, that says that there are no electrons being added or subtracted to it. It's just neutral. So good. That's number 1. That's the easiest rule we can follow right now. Rule 2, very lengthy. We'll get to that when we have to get to that. That's not necessary right now. Rule 3, though. If you ever see fluorine inside of a compound, if it is added to a compound, we learned last time that fluorine has the most electronegativity, as in it's going to rip off as many electrons as possible. So if fluorine is ever with anything, it always has an oxidation number of -1. So if you see fluorine in a compound, automatically, directly above it, you need to write -1. Period. There is no ands, ifs, or buts. There are no exceptions. It's always -1. So once again, if you see fluorine, F, in a compound, right above it, you put -1 for its oxidation number. Same rule goes for oxygen. Oxygen in our class is always going to be -2. You won't even have to think about it. You guys are going to be doing this over and over and over and over again. Now, there are a couple exceptions. We won't worry about those in Chemistry 1. So oxygen always has an oxidation number of -2 when it's combined with another element. You don't have to think about it. You don't have to look at your sheet. You see oxygen, you see -2 over it. That's how many electrons it's always going to give. It is always wanting to get 2 more electrons. That's why it's -2, gaining 2 negative electrons. Same with fluorine. Like I said before, fluorine is always going to add 1 negative electron to itself to make it happier. Another one that's pretty easy is number 5. If you see hydrogen with any non-metal, if it's with oxygen, if it's with fluorine, if it's with chlorine, if it's with bromine, any type of gas, it's +1. If you see it with a metal, it's -1. So on your purple sheet right now, right next to your box that says fluorine, it says +1, -1. Right next to it, write +1, which should be already there. Put a dash and write non-metals. Where the -1 is, put a dash next to that and write write with metals. By the way, over on your sheet, so by the way, there should be a -1 here for you guys. This is going to be your metals. +1 is non-metal. Sorry, my writing's a little sloppy. Whew. Over here, I already crossed out. There was a +2. I want you guys right now to get rid of the +2 on yours. We'll never use it in this class. Get rid of it. So the only number you should be seeing on your oxidation number chart is -2 for oxygen, -1 for fluorine, and you should have +1 dash non-metal, -1 metals. And if you ever need to go back, just stop this and rewind it, and we should be able to go. We're going to go on to the 6th rule, and then we're going to do some example problems so we can kind of clarify what's going on. Number 6 says atoms in neutral states have oxidation numbers sum equal to 0. What does that mean? Alright, so let's get that sheet of paper out that we're going to do example problems. Maybe you're going to be doing it on the purple sheet, maybe it's on another sheet of paper, but we're going to do some example problems right now. So how this is going to be written out is example number 1. NaCl, sodium chloride, our standard salt solution. On the top, across the top here, your numbers are going to be here. These are going to be oxidation numbers above here. These oxidation numbers are going to be coming from, and yeah, I know it's disappearing. Those two numbers are going to be coming from this sheet right here. That purple sheet is going to give you the numbers that go across the top. Now, for some you don't even have to worry about this bottom area. Some of them are going to be very easy to do without having to do any math. But if we do have to do math, it's pretty easy. So let's say right now, let's see what oxidation numbers we can use for NaCl. So let's go to our sheet. We've got Na. Na is awesome because Na only ever has whoopsie. Whoops, whoa, 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 whoa. Sorry. Wow, this is crazy. So Na only ever has, let's see if I can do it better this time. Nope. Na has a +1 charge. So it doesn't matter. Just like fluorine always has a -1, aluminum's always going to have +3, sodium's always going to have +1, lithium's going to have +1, beryllium's going to have +2. So there are some elements that are automatically, you don't even have to think, you look on your purple paper and you write it down. So for this one, we go back over here. Na, as we just saw on the sheet, only has one option. The option is, let me do different colors here, +1. That's the only thing we can ever do above sodium when it's combined with something. So it's +1, so we're halfway there. So on this compound, sodium is saying it's giving up 1 electron. What about chlorine? We'll go over this purple sheet. Whew. Now chlorine has +7, +5, +3, +1, and -1. Well, which one is it? Well, that's where the very simple math comes into effect here. So we have all these options. So what do? Alright, so let's go back. So we're going to do some addition, we're going to do some multiplication and division now. On the bottom, we're going to do some math. And on the bottom is the sum of the oxidation numbers. And that was rule number 6. It said atoms in neutral states have oxidation sums equal to 0. So we're going to put a 0 on the bottom because this whole bottom is going to equal to 0. Well, when you are working the oxidation numbers, and if you're going from the top using the oxidation number, if you're going down, you multiply. And you multiply the oxidation number by its subscript right here. So +1 times 1, because there's one of them, is +1. Now, we already have that figured out. Well, we need the bottom. The bottom gets equal to 0 just like most equations. What are we going to have to add? So we have +1. If we're going to add that to another number, we've got to have both sides equal to 0. So what number, everybody, do we add to 1 to get to 0? Hopefully, our simple math says we add a -1. If we add a -1, 1 plus -1 is 0. So our bottom equation works. So what does that mean? Well, that's the number right here that we're going to take, and we're going to, when we go up in a direction, we divide. So we take this number, -1, chlorine has 1, so -1 divided by 1, everybody, is, thank you for probably the one person that might have said it, maybe 2. And those people would be hopefully correct at -1. And now you are officially finished with your oxidation number. I know it looks a little messy, but in the end, what numbers matter the most are these two numbers. Sodium, it's saying it's giving up 1 electron, so it's plus 1 electron. Chlorine, through the math that we did, is negative 1, so it's gained 1 electron. Now this makes sense because we know sodium and chlorine, one's got an electron on the outside, and chlorine's always looking for a negative 1, so this kind of makes sense. And to make sure that chlorine is negative 1, we go back, and sure enough, chlorine has a negative 1 charge for an option. So your answer on the quiz test, when you get to write it, would be right here. NaCl, and it would be Na plus 1, Cl minus 1, and that would be your oxidation numbers, would be the colored ones. These are your symbols, and all this other stuff is just math to figure out these two numbers. Hopefully we haven't totally confused you guys yet. But once again, all we're doing is we're giving a compound like NaCl. We want to know where the electrons are going. These, once again, with covalent bonding, ionic bonding, everything we talk about the rest of the year is going to be doing with electrons. Alright, and we're back. Hopefully everybody has Al2O3 on there. Now, right away, don't get all frustrated. So we have aluminum oxide. We want to know how many electrons each is giving up or taking. So we go back to our rules and we see if we can figure out either one of these very easily. So we go back to our rules. Alright, all pure elements. That's not a pure element, so it doesn't work for number 1. Number 2 we're not worrying about right now until we have to. Fluorine is negative 1. We don't have that. Oh, right here, numero 4, numero cuatro, oxygen is always negative 2. So let's go right back. Boom, boom. Right above here, let me get my correct color here. We just said always oxygen is negative 2. So right above there, we don't even think. We look at our sheet and we say, yep, automatically negative 2. Now, what about Al? Alright. Let's see. Well, right here we can use that. Oxygen, yep, always negative 2. My oxidation chart says plus 3 is the only one possible for aluminum. So it's a plus 3. Alright, so let's go over to our problem. Let's get our purple pen here. And plus 3. So this equation is saying that in aluminum oxide, when we put aluminum and oxygen together, every aluminum is going to give away 3 electrons, and oxygen is going to take 2 electrons. Now you're like, that doesn't make sense because how is it 3 and negative 2? Those don't add up. Well, the problem is, to make sure that these are right, because these don't have to equal 0. When you multiply them across, they have to. So as in, let's set this to 0 on the bottom. And let's do some math. So, remember when we go down, we multiply. So negative 2 times 3, right here, is going to equal, hopefully you guys said, yep, negative 6. And plus 3, once again we're going down this time because we have both numbers already up there, plus 3 times 2 aluminums, because there's 2, and that's plus 6. So in aluminum oxide, there's 2 aluminums, there's 3 oxygens, and with those 3 oxygens, every oxygen gains 2 electrons, and for every aluminum, they lose 3 electrons. And that's all this is saying, that aluminum gives up 3 electrons, oxygen gives up 2. Oxygen takes 2. and we did the math, and we figured out plus 6 minus 6 equals 0. Alright, let's go to another one. Alrighty, phosphorus and oxygen in the arrangement of P2O5. P2O5 would be diphosphorus pentaoxide. So right away, we see this oxygen. Don't even think. I know this isn't natural to you guys now, but later, if you guys are doing oxidation numbers and you see O, boom, right away, -2. It is always going to take 2 electrons. And let's go back and make sure that's right. Rule number 4. We don't even think about it. It's just natural. It comes to us. It says we see oxygen in a compound. We're going to put a -2 above it. And that's what we did. We put -2 open, and it says oxygen is taking 2 electrons every single time. What about phosphorus? Is phosphorus as easy as oxygen? Let's see. Oof. No. Phosphorus has a +5 option, a +3 option, a -3 option. Maybe on your paper it has even more options. So unlike oxygen and fluorine and aluminum and silicon, where there's only like one option and you can't even think about it, you just do it, phosphorus, we got to do the math behind it. So let's see it. Once again, we set the bottom, since this is a neutral element, we set this bottom to 0. So when we do the math, it's going to all equal 0. So when we go down, once again, we we multiply. So -2 times 5. And I know Mr. Willett, Mr. Disrael, and Mr. Zeil will be happy right now when you guys would say -10 to the answer of -2 times -2 times 5 is -10. So your math teachers will also be hopefully happy for you to say, all right, we have a -10. How do we get to 0? How many do we have to add to -10 to get to 0, to make it neutral? And you guys have all said, oh, very good, very good. Let me get another color up here. All +10. So +10 minus 10 equals 0. So how does that help us? Well, that gives us the number that now we can divide by. So we got 10, and once again we're going up, and when we go up, we divide numbers. So 10 divided by 2 is, wait for it, wait for it, wait for it. Oh, that's right. It's +5. And that's what our math says. So it says that phosphorus, when combined with oxygen, every single phosphorus will give up 5 electrons, and every single oxygen molecule will take 2 electrons. And if we go, let's make sure that +5 is an option for phosphorus. Oh, it is. We did it right. Fantastic. Oh, yeah. So hopefully you guys are getting this. This is nothing complicated. For those people who are like, oh my god, yeah, right, Mr. Preisel, don't overthink it. It's just simple math, and we're just multiplying and dividing and putting some numbers above some elements. That's it right now. Nothing further than that. Alright, so let's go on to number 4. And now, once again, I just said there's nothing complicated, and now you guys are looking at it and like, oh my god, there's 3 numbers, what am I going to do? And hopefully, Dane, you're up, and you're not sleeping, and Haley, if he is, please wake him up. And if he's being sassy or salty, please simmer down. Alright, so, let's look at this, ladies and gentlemen. We have 3 elements. Now, this doesn't make it any harder, it's just different. And it's just different because we have to do 3 instead of 2. No difference in what we do. So we go through and we look if any of these automatically have numbers that only show up once. So sodium, hydrogen, and oxygen. Let's look over here if we can do some easy work. Well, hydrogen's got 2, so we don't know right off the bat. Metal, non-metal. Alright, let's see if Alright, sodium. Oh, sodium only ever can have +1. So we go back, scroll down. Guess what? Sodium has to be +1 because that's the only one it can ever be. Sweet. And hopefully when we were doing this, you guys saw oxygen and you're like, ding, 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 ding. Oxygen, rule number 3, I believe, or 2. 4, my bad. Oxygen is always -2 for us. So we go back, and I think we're already 2/3 done, everybody. We got sodium that says it's giving up 1 electron. Oxygen is always taking 2. So now we're left with hydrogen. And unfortunately, hydrogen has 2 options. It can be a +1 or a -1. And so we'll just do some simple math. This is neutral again. So we'll set this to 0, and we'll do our math. We'll start over here. We'll go down, and +1 times 1 is +1. Oxygen is -2. There are 1 oxygens, so you multiply that. -2 times 1 is -2. Now at the bottom we have 1 number left. So we're dividing these up. One times 1 is +1. -2 times 1 is -2. Now hydrogen, what does hydrogen get? Well, let's think about this. You have +1, you -2, that's -1. Now to get to 0, you need another, that's correct, +1. So +1 goes down here. So it's +1, -2, +1. And remember, when you go up an oxidation number, you divide. So +1 divided by 1 is +1. And bada boom, bada bing, ladies and gentlemen, we are done with this one. NaOH has oxidation numbers of +1, -2, and +1. Now, once again, I know this is like, why are we learning this? Well, we're learning this because later on, when we talk about bonding, it's going to be very important to figure out what's going on with these. So let's go to another example, and let's just keep doing it, practice and practice and practice. Let's see here. Alright, let's try this one out. So oxygen, right off the bat, right there, I see it, it's -2, it's always -2, it's always -2. What did I say? That's right, -2. Madeline, I hear you in the back, I hear Madeline say -2 when she sees oxygen. I do. I really, really do. Hopefully Madeline's there. If she's not, this made it really weird. But hopefully, Adeline, you're up. So, thanks, Madeline. So we'll put a -2 up there. Alright, that's automatic. We already know that one. K, we'll see if we have an option. No options for K. K is always +1. Man, we're cruising again. This is +1. Sulfur, what's sulfur? Alright, let's go back. +6, +4, -2. Nope, we gotta do the math behind this. Alright, so let's do this. We gotta set this to 0 on the bottom again. We're doing some multiplication to go down, so +1 times 1 is +1. So that's -1. Oxygen is -2 times 4. So we're going down, we multiply. This is -8. So we do some math. You have -8, you got a +1. You got to make it equal to 0 on the other side, so you should need to add. Very good. It is +7. And if we go up, remember, we divide. So we do 7 divided by 1 is +7. So your oxidation numbers for this are +1, +7, -2. But you always have to make sure that you guys double check it. So we go back over here. And sulfur doesn't have a +7. And I know we did the math. That math is not that hard. +1 times 1 is 1. -2 times 4 is -8. Yep, that works. So sometimes we'll have answers that we can do mathematically, but they're not possible. So you just write not possible by them. Well, hopefully the hour's not up yet. If it is, sorry, but if it isn't, we're going to stop right here. We do have some homework for you guys to do. I want you guys to do those same sample problems, 1A through, I think, J. I want you guys to show the math like you guys were doing here. So, once again, do the same sample problems, 1 through number 1, A through J. Answers in the back, but I want to see the math for that this time, as in doing this multiplication and division, showing this bottom numbers here. Alright, thanks, and have a good weekend.